Algebra 2, here we are with infinite series. So we've been working with series instead of sequences here in 10b. And for a series, we know we add up. We do the sum of all the terms in the sequence. But today we have an infinite series, meaning it goes on forever. Forever. So what would the sum, sigma notation, what would the sum be of all these terms? Okay, if I put in 1, 2 times 1 is 2, plus 5 is 7. In the next term, times 2 times 2 is 4. And then plus 5 more would be 9. And then we'll have 11, and 13, and 15, and 17, and it's going to keep going up by 2 forever. Is it possible to be able to add all these up? And the answer there is no, because each term keeps getting bigger, so every time we keep adding more and more, it's going to get bigger and bigger and bigger as you go. Okay, what about a multiplication one? 3 times 2 to the n minus 1 power, infinite, from 1 to infinity and beyond. If I plug in 1 minus 1 is 0, 2 to the 0 power, anything to the 0 power is 1, times 3 is 3. Okay, then 3 times 2 would be 6. 3 times 2 to the second, 3 times 4 is 12. 3 times 2 to the third, 3 times 8 is 24. And it keeps doubling. 3, 6, 12, 24, 48, 96, ... Would you be able to ever add all those up as it keeps growing to infinity and beyond? The answer is no. Okay? You're not going to be able to add those up. It's going to grow infinitely. So, Mr. Handke, how are we going to ever add these up? One more problem. Let's look at this. 4 times a half to the n minus 1. Okay, we know our first term is going to be 4. And then we cut it in half. 2. Okay. 1. A half. A fourth. An eighth. And a 16th. ... Okay, if our ratio is a half, each new number is getting smaller, and actually we're at 1, we're at 0.5, 0.25, 0.125, we keep getting smaller and smaller and smaller. Eventually these fractions get to be so small that they're basically 0. Eventually they get so small it's eventually 0. And if you're adding 0, you're not adding anything anymore. So we could technically find a total. Whoa. How about that? You can find the sum of an infinite geometric series if your R value is less than 1. Absolute value is less than 1. Could be a negative fraction less than 1. Could be a positive fraction less than 1. Okay, and that is a convergent series because it converges on an answer. And this is like the convergent divergent, kind of relates to that movie series Divergent. Okay, a divergent series does not have a sum and does not approach a specific value. And that's when your multiplier, positive or negative, absolute value of it is greater than or equal to 1. If it's equal to 1, that means it's staying the same number over and over again. 4, 4, 4, 4, 4. You're just adding 4 every time. It's going to keep growing. So if you have an infinite geometric series and the absolute value of your R is less than 1, it's a really easy formula too. It's just A1 divided by 1 minus the R. Crazy. So if we were doing the top one up there, your A1, your first term, your G1, I guess, was 4, and our R is a half. So we would have 4 over 1 minus a half. That's 4 over a half, or 4 over 0.5. Dividing by a half is the same as timesing by 2, and the total would be 8. Whoa. Whoa, we just did the sum. We just added up an infinite number of terms. Because eventually, those numbers get so small that it's basically 0, and you're adding nothing. And we can figure that sum out. All those terms would add up to 8. Crazy. Turn the page. Okay, determine if that given series is a convergent series or a divergent series. If convergent, find the sum. Okay? So our first term is 16, our second term is negative 8. So you remember how to find the R? You go backwards. Negative 8 divided by 16 is negative a half. So our R value is a fraction. It's less than, the absolute value of it is less than 1. Okay? Which means that we can do it, which means that it's divergent. So we can do it. So we'll have S1, or A1, 16, divided by 1 minus negative a half. So this is 16 over 1.5. 1 minus a negative is a plus. 16 divided by 1.5, 10 and 2/3. 10.6 repeating. Okay, 48 divided by 32. Go backwards. Equals 1.5. Okay, 1.5 is bigger than 1, so this one's growing. So it is, I had those flipped. That's convergent. Divergent's a good movie, but convergent's the one you want for math. Convergent. This one's divergent. Does not approach a specific value. Okay, and then 1, negative 1, 1, negative 1, 1, negative 1. Okay, doing our division, negative 1 over 1 equals negative 1. Okay, it's not a decimal fraction there. Absolute value of negative 1 equals 1. And that's why we have this greater than or equal to. So it is going to be divergent. And we won't be able to find the total because it's going to be keep going. It's not approaching anything. I got 2 options for you. Well, 3 options depending on, I guess, how far you're going or what you're looking at. It could be 1 or 0. I suppose 1 and then it's 0 and then it's 1 and then it's 0. I was going to say negative 1, but I guess if it starts with 1, it'll never get to negative 1. So it's not really ever approaching. The sum is never getting closer to one thing. It's flipping back and forth. All right, your turn here. I guess I'll do one of these. Okay, find the sum of each infinite series if it exists. And just quickly glancing at these, I do believe they all exist. So we got 440, 220, 110, ... forever. So going in reverse, 220 over 440 equals 1/2. So that should mean that we should be able to find the sum because it's a fraction less than 1. Okay? So we're going to take the first term, 440, over 1 minus the r. 440 divided by parentheses 1 minus a half, or 0.5. Make sure we're using parentheses. We should have 880. Okay, let's have you try this one. Ready, set, go. All right, let's check it out. If you need more time, go ahead and push pause. Okay. 150 over 600 should be a fourth. That is less than 1, so yes, it exists. So we do 600 over 1 minus 1/4. Again, this is another one that you could do a decimal on the bottom, but we still need parentheses. Divided by parentheses, 1 minus 1/4, 800. Okay, an infinite one, okay, it's with sigma notation. Remember that your first one is right there, and this is your r. Okay, so 3/4 is smaller than 1, so it should be a yes. And we're going to do 1/2 over 1 minus 3/4. 0.5 or 1/2 divided by parentheses 1 minus 3/4 or 1 minus 0.75, and that's going to be a 2. 1 minus 0.75 would be a quarter or a fourth, and a half divided by a fourth is 2. Okay, your turn to try this one. Ready, set, go. Okay, let's check it out. We have 4/5 for the r value, so yes, we can. We'll have 3 over 1 minus 4/5. 3 divided by parentheses 1 minus 4/5. 15. Now, what would 1 look like that is a no? Okay, well, up here we saw that it was growing, and when I divided it, my r value was bigger. It was greater than or equal to 1. If it equals 1, it's a no. If it's bigger than 1, it's a no. We need it to be a decimal, positive or negative decimal, less than 1 or smaller than negative 1. Okay? If you had like something like this in sigma notation, if your multiplier was like 5/4, instead, if it was flipped, that was 5/4, then that would be bigger than 1, and we would not be able to do it. All right, folks, thanks for watching. Hopefully this was helpful. Good luck on your homework, and let me know if you have any questions.